Greetings. So today I'm going to show you our embedded system project based on smart temperature detection system. And first things first, we're going to start with the components. We have our mobile phone right here, which will be essential for showing the Bluetooth output. Our Arduino board, which is the microcontroller. Our HC06, which will be essential for Bluetooth connection. Our RGB LED light, which will be showing different color coordination based on the temperature range. Our power supply and our temperature sensor right here. Jumper wires, which are used for circuit connection, and our matchbox, which is essential for testing different temperature ranges. First things first, you're going to connect the USB cable of the Arduino board to the computer, which I've done so. Then open the Arduino IDE, which will contain the code for running our system. Then we're going to run the code right here. We're going to compile the code to check if there are any errors with the code. Yes, when the code is done uploading on the serial monitor, it will start displaying the output. There will be different output on the temperature. This temperature is based on our room temperature that we have currently. This is our room. Based on our room temperature that we have. So the next thing you're going to do, we are going to connect our Bluetooth connection. So that's how we are going to connect. Then to connect, we then have to connect our HC06 device to our mobile device right here. This is called a Bluetooth controller for Arduino, the app. So this is our device. Our device is known as HC06. Once our device is connected to our Arduino system, and you can see that the values on the serial monitor and the ones on the mobile phone are exactly the same. As you can see right here, the values on the monitor and the serial monitor of the computer and the terminal on the mobile phone are exactly the same. Now we test the system using our matchbox to test the different temperature ranges. When the Arduino board is green, when the LED light is green, this shows that the temperature is at a normal state. When it changes to blue, this shows that the temperature is warmer. Then when it changes to red, meaning that the temperature is getting hotter. So we are going to test it using our matchbox. So here we're going to test our temperature using the temperature sensor. And once the temperature goes up, we realize the RGB LED light has turned to red, meaning the temperature is increasing at an alarming rate. So the user should take an action. So the buzzer goes off, and when we check on the serial monitor, we discover that there's a message here being displayed that the status is hot and the buzzer is on. One should either contact the fire department or the medical department in case of an emergency. Also, as the owner of the system, you can manually override the system by turning on the buzzer manually on the terminal as shown by writing the command on, and the buzzer will start ringing, but the RGB LED light won't change, but the buzzer will be ringing. Then once you want to turn the buzzer off, you write the command off. You write the command off right there, and you switch it on. The buzzer will go off. Even when the temperature is high, you can also turn the buzzer off using the terminal command. And to return it back to its default state, you write the command auto, which will return the system back to to its automatic state default mode. Yeah, so you can see here status of the system is the temperature of our Arduino board. It's warm. That has been detected. It's warm, which is blue. Yeah. That's it. That's our prototype for our today's project, and these are its features, and I've uploaded the document to further explain on this video on the virtual campus. Yeah.